Alrighty, we are continuing our study of quadratics. We are actually looking at some different forms of quadratics and then also talking about the graphs of them. As of right now, you only know that the graph of a quadratic looks like a U, either opening up or down, but we're going to make that more specific to connecting the equation to the graph. Before we get into that, though, I wanted to remind you the start thinking part here says the following are two equations to represent the same function. Explain what the benefits are of each of the forms. So the first one is in standard form, ax plus by equals c form, and the other one is in slope-intercept form. You guys should remember that that first form is really nice when you're trying to find an x and y intercept and graph that way, because you can cover up the term with the y in it and solve for x, and then cover up the term with the x in it and solve for y, and that will get you your x and y intercepts. Whereas the other one is great for finding out what the slope and the y-intercept are. So even though they mean the same thing, they're representing the same function, one of them is better when you're trying to graph using x and y-intercepts, and the other one is great when you are trying to graph using a y-intercept and a slope. Now, you have these other three quadratics now. Now we're looking at some quadratics, and while they all look different, the students simplified the one for a and got x squared plus 2x minus 8 when they FOILed. The next one was already x squared plus 2x minus 8. And the next one, when they FOIL and then subtract 9, they get x squared plus 2x minus 8. You could see that all of these are representing the same function. They are just in a different form. What you are going to learn is that a is in a form called factored form, b is in standard form, and c is in vertex form. And each one of those will give you different information about the graph. It might tell you where the x-intercepts are, or what the y-intercept is, or where the vertex is. What we're going to be focusing on today, though, is standard form. Standard form is when the quadratic is in the form y equals ax squared plus bx plus c. And the a value is going to be the number attached to the x squared, the b is going to be the number attached to the x, and the c is just going to be the number by itself, the constant. While sometimes you won't have a b or a c value and they will be 0 because that term doesn't exist, you must have an a term. Here's an example. Y equals 3x squared plus 2x plus 5. The a is 3, the b is 2, and the c is 5. There are no x's in there. Those are just the values. What we did was we looked at when you are in standard form, what happens as you have a b term, or what happens as you have a c term, or what happens as you change your a term. So the first thing we looked at was we pulled out Desmos and we graphed the parent function, y equals x squared, or f of x equals x squared. And then we changed the c value. We added 2 or subtracted 3 or subtracted 1 or added 3. And what we found is it kind of looked like it was shifting up or down. Now it's not technically shifting up or down, it's just changing the y-intercept. So what we found was that the c value is just the y-intercept. You should also know the exact points of the parent function y equals x squared. It's at 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. It's basically just substituting in the numbers negative 3, negative 2, negative 1, 0, 1, 2, 3, and you could do more than that. And then you just square them to find out the y's. So you should know where those general points are. So the first thing the students learned was that the c value is going to change the y-intercept. The next thing we looked at was changing the a value. It changed it from either being positive to negative and also changed the value of it, either making it larger than 1, the absolute value of it, or between 0 and 1. What we found was that if it was positive, then it was going to be opening upwards, and if it is negative, it is going to be opening downwards. The other thing we noticed was that the wideness or narrowness of your parabola changed depending on the number in front. And what we found was that if the absolute value of that of a was greater than 1, so 2, 3, 4, 5, 6, 7, 8, or negative 2, negative 3, negative 4, negative 5, negative 6, negative 8, and so on, then it was going to become narrower than it was before. And if it was between 0 and 1, the absolute value of a, then it is wider. And the reason why this works is instead of having y equals x squared, if you add y equals 2x squared, it's just saying all the points need to be twice as high. Instead of over 1, up 1, it's going to be over 1, up 2. And that is going to end up making it narrower. If it was y equals 1/5 x squared, instead of over 1, up 1, it's over 1, up 1/5. And when you do that, it just makes it so that it is going to be much wider. So the A value is going to make it open up or down. It's also going to make it narrow or wide based on these rules. The last thing we looked at here was we did not change anything at first except for the B value. And what we found was that the y-intercept stayed at 0 as we knew it was going to, but it seemed like it was shifting the graph left or right. We hadn't seen that before. Now, we were trying to come up with a rule of maybe if you take the number and you divide by 2, you'll always find out how much it shifted, but it didn't work. It was at this point in our study of quadratics, all we know is if there is a B term, it is going to shift it left or right, but we don't know exactly how. We'll learn that in the next lesson. So the B value is going to shift it left or right, but we're not quite sure how. When we were looking at these problems right here, we tried to figure out the general characteristics and made a graph. So on the first one, we knew that that thing was going to be narrower than the parent function because 3 is greater than 1. It is going to open downwards because it is a negative. It did not shift left or right because there was no B term, and the y-intercept was at 0, 5. So I made a graph that was narrower, opened downwards, and had a y-intercept of 5. If you wanted to be even better, instead of going over 1, down 1, like the parent function, it would be over 1, down 3. And then that would give you 3 nice points to work with. The next one here is going to be wider than the parent function. It's going to open upwards. It is not going to shift horizontally because there's no B term, and it is going to have a y-intercept of -2. And you could see the graph that I did with that one. The next one is going to be the same as the parent function. It opens up. It is shifted left or right. We're not quite sure which direction, but it is going to be shifted. And then it is going to have a y-intercept of 3. So I made my best graph with that information in mind. And then on the last one, we know it's going to be wider because all the points are going to be 1/5 as high or low as they were before. It is going to open downwards. It is not going to shift left or right. And the y-intercept is going to be 4. All right, now let's take a peek at the homework. On here, you are trying to use your rules to narrow down which graph is which. There is only one graph that has a negative, or that opens downwards, and only one equation that has a negative A value. So you know B goes to that last graph. I would probably go to the y-intercept. There are 2 of them that have a y-intercept of 2, but one of them looks like it should be shifted left or right. You could see that the only graph that has been shifted left or right is the second to the last on the right, and the only equation that has a B term is D. So you know that that one goes to D, and then you can go from there trying to figure out which one is narrower. You can see that the first graph is narrower, and the only equation that has a value greater than 1 is 3. For number 2, it says, give all the reasons why this cannot be the graph. Well, you know it's supposed to be opening downwards. You know that it is supposed to be shifted left or right because it has a B term, and it's also supposed to have a y-intercept of +2, which it does not have. And then on our last one here, it says explain all the characteristics of your graph and then go over and make a basic sketch. It should be opening downwards. It should be fairly wide. It's going to be wider than the parent function. It should be shifted left or right. We're not sure which one yet because we haven't learned that yet. And it should have a y-intercept of 0, -1. When you have all of those things, it could be one of those 2 graphs. It's technically the one that I have the arrow pointed to, but we're not quite sure why that is. We'll learn that tomorrow. All right, hopefully all that made sense. The A value, the B value, and the C value will change the graph, either flipping it or making it wider or changing the y-intercept or shifting it left or right. So this is going to make it so that you can figure out if your graph is reasonable or not. If your graph is opening up and you know it's supposed to open down, then you would go back and try to figure out what you did wrong. If you know it's supposed to be shifted left or right and it's not, then you try to figure out what you did wrong. All right, thanks for watching.